Linear functions is the topic for this video. Hafaday Todes let's get started. Let's go take a look at this function and describe the rate of change, also known as the slope. You can see it's increasing because it's going up, so in our vocabulary we call that a direct function, meaning that as x goes up, y also increases. Now, the next question is, what is the y-intercept? So we check our y-axis and we see it crosses at the number 4. The next question is, what is the rise? So we have to create our triangle using the corners on the graph. So we find one at the intercept and one close by. Notice we're working in units of 1 on the x and y axis. So the rise is 2 boxes high, so our rise is 2. And our run is 3 boxes long, so our run is equal to 3. Now we need to put those together to create the slope denoted by the letter m. Remember, slope is equal to rise over run. And so we take the rise 2 and we put it over the run 3, and we see that our slope is 2/3. Note that 2/3 is already in simplest form, so it's our final answer. Now we can take the y-intercept of 4, and we can take the slope of 2/3, and we can combine them to write our function. So we get y is equal to the slope, which is 2/3, x, plus the intercept, which is 4. Now we want to look at the graph and ask ourselves, if x is equal to 6, what is the value of y? So go up from x is 6 and go across to find the y value, and you will see that y is equal to 8. Now we're going to take that coordinate and the whole function in general. We're going to try to apply it to a real-life problem. We're going to go ahead and let the x-axis equal the weeks, and we're going to let the y-axis equal pounds. Now, remember that our starting point is the y-intercept, and the y-intercept is 4. So that's 4 pounds. Whatever our word problem is starts at 4 pounds. Now, our word problem is going to change at a rate of rise 2 pounds to every 3 weeks, which is the run. So 2 pounds for every 3 weeks. Again, that's our slope. So now we just have to come up with a topic for our word problem. And it would be something that starts off at 4 pounds and then every 2 weeks increases 3 pounds. The topic for the word problem that I chose is going to be a puppy. So the word problem that I wrote was about a puppy, and the puppy weighs 4 pounds at birth. That's the y-intercept. Every 2 weeks it gained 3 pounds. Because 2 weeks is the rise, 3 pounds is the run. So it changes at a rate of 2 weeks and 3 pounds. How heavy is the puppy? Well, at 0 weeks, the puppy is already 4 pounds. We could see at 3 weeks, it corresponds to 6 pounds on the y-axis. And then if we look another 3 weeks further, at 6 weeks, it corresponds to 8 pounds on our graph. So at 6 weeks, the puppy is a nice healthy 8 pounds. And that's it for this problem. Let's go ahead and move on to another type. Let's go notice a couple things about this graph. First of all, the boxes are in units of 10. And if you look at the rate of change, it is increasing again. But if you compare it to the first problem we did, it is increasing directly at a much slower pace. So we're gonna go ahead and note that down. Now let's go take a look at the y-intercept. So we look at the y-axis and we see it crosses at 40. We're noting again that it increases in units of 10. So make sure you keep that in mind, especially when we're looking at the slope. So let's go create our triangle for the slope. There's one corner and there's another corner. So we create our triangle and we see that our rise is 1 box. But reminding ourselves, the boxes are units of 10. So the rise is 10. And since the run is 4 boxes in units of 10, it is 40 units. So our rise is 10 and our run is 40. Put it together to get a slope of 10 over 40. And we simplify that to 1/4. Let's go put both of that together to y equals the slope of 1/4 x plus the y-intercept, which we remind ourselves is 40. And here is our function for the line. Now let's go clean things up a little bit and check. What about when x is equal to 40? What is the value of y? So we find 40 on the x-axis and we go up and it lines up on the y-axis to 50. Let's go apply this function and that coordinate to a realistic real-world problem. So let's go have x equal the days and y be dollars. So we're going to note our x-axis is days and note our y-axis is equal to dollars. And we're going to find that our y-intercept is our starting point. So it starts off at $50 because we're talking about the y-axis. So we need to change things at a rate of $1 per day. Or we could use the form of $10 for 40 days, which is what our original triangle was. We're going to remind ourselves that our slope is equal to rise over run, and that's how we got our rate of change. So if our slope was 10, that's $10. That's the unit that we're talking about. And our run, which goes side to side, is in units of days. Our slope run is 40 days. So we're going to go ahead and write a word problem involving money, where Miss Bermuda starts off with $40, and I save $10 every 40 days. So the question is, how much money have I saved up? Now the answer to that is really going to depend on how many days have passed. So remember, I started off already with $40. So on 0 days, I have $40. Then if you go out further in time, once it hits 80 days, that corresponds with $60. And that's it for our review of functions. If you have any questions, you can go ahead and email me. Thank you very much, and adios.